Hi folks, in today's video we're going to be looking at the electronic configuration of ions this time as opposed to atoms. So if you want to learn how to write the electronic configuration, please keep listening. Let's have a look at the periodic table. The periodic table we can split up into 4 different blocks, your S, P, D and F. In advanced higher we don't really need to worry about the F block, we only care about the S, P and D block. So how do you know if an element is an S, P or D block element? Well, you're looking at the last electronic configuration. So for example, your group 1, they all are 1s2, 2s2. That means that they are going to be an S block element. So it's that last electronic configuration. So whatever the last one that you write is going to be if it's an S, P, D or F block element. Just some general rules to learn before we start writing the electronic configuration of ions. The most important one here is your 4s fills and empties before your 3D subshell. Now I know that goes against what we've been taught before previously, but it is important that your 4s fills first and also empties first as well. And you've got 2 exceptions to this, is chromium and copper. They don't follow Aufbau's principle because there's a special stability with either having a half-filled or a filled D subshell. And then finally, metal atoms will lose electrons and form positive ions, and then non-metals will gain electrons to form negative ions. So just to remember that when you're writing your electronic configuration. Well, let's have a look at chromium and copper since they are slightly different from all the other elements that we're aware of. Chromium has an electron arrangement of 24, well it's got an atomic number of 24. So let's start by writing out what we know so far. So I've got a 1s2, 2s2, 2p6, 3s2, 3p6, and this is where we stop. This is where it's slightly different. Instead of writing 4s2 next, in actual fact we write 4s1 and then we write 3d5. So the 3d5 is the most important thing here because it has a half-filled D subshell. So let me just draw that underneath. So with your D subshell you can have 5 boxes, so a total of 10 electrons, and with your chromium they're all going to be filled singly, and that's got a relative stability on its own. That's why chromium is slightly different from all the other atoms. With copper it's got 29 electrons, so let's draw and write it the same way. Again we start off with 1s2, 2s2, 2p6, 3s2 and 3p6. Again, this is where we stop. We should be writing 4s2 next, but in actual fact we're only writing 4s1, and it's because we have a 3d10. So that 10 is the most important thing because that's completely filled. So let's draw it again. So it's very similar to the one above where you're going to have your 10 electrons that can fit in the box. It's going to be completely filled, and that's got a special stability on its own. So that is why copper and chromium don't follow Aufbau's principle, because they've got their own stability with that half-filled or filled D subshell. That's us finished. A relatively short video today, so hopefully that makes sense for you. Feel free to have a look at the questions on page 30 of your inorganic book. And apart from that, I'll see you all later.